All right, there. Now we are at the last part of our chapter 2. We are going to talk about property of water. Water can be liquid, solid, right, or gas. It's very essential to our life. And you remember that molecule of water create a polarity, right, H2. And this is this polarity that will make water that you are drinking. Oxygen is more electronegative than the hydrogen, right? So the oxygen is partially, the part where the oxygen exists, H2O, will be slightly negative, and where the hydrogen exists will be slightly positive. The overall molecule has no charge, right? And this polarity that the molecule of water has will making it having the ability to interact quickly with other substances. So by this polarity, this is why we have water, because the slightly negative H2O will interact with the slightly positive H2O, etc., etc. That will, because this polarity will making this molecule H2O interacting with each other, making water. Here is one. And this is what we call cohesion. Polarity of water allows molecule of water to be attract to one another. Cohesion. Hydrogen bonding is not very strong molecule, but because we have so many, it make this surface of the water very high. We call that surface tension of the water much higher. Look at the insect, he's not growing because of this surface of tension of the water, very strong. We also have another property, adhesion. The water has tendency to also interact with other substances other than water, like capillary tube. When you put this little capillary tube in any solution of water, you will see the water that it's stuck and it starts going up, stick to the other polar molecules. And the adhesion is also the property that the water use with the sound to make a castle. Like here in Vancouver, the grain of sand have a silicon, which is another substance that will interact with the water. Adhesion. So we can build castles because the water is attracted to the sand by adhesion, and the water is interact with each other by cohesion. Other properties of the water. Water has high specific heat. When it's very hot and you look at your pool and you're walking in your pavestone, you can't, it's very hot, your feet get hot. But when you touch the water, it's cold because the water has a specific high specific heat. So large amount of energy is required to change the temperature of the water. The water will become warm during the night. The water also has a high heat of vaporization. This is why the city that exists by the oceans, when it's very hot over here, we are very hot. By the oceans, we are cooler because the evaporation of the water from a surface causes cooling that surface. And another thing, when you put a bottle of water in a freezer, he gets freezed, right? Then it explodes because actually the solid water he become more dense. This is why your bottle of the water, it's not exposed, can break down. It's not exposed. Sorry about the term exposed. I am funny. And also when you put a piece of ice in the top of water, and the water, what's going to happen? It floats because it's less dense than liquid, the solid water. The bodies of water freeze from the top to down. This is why we have those floodings. The hydrogen bonding is more stable when it's cold, right? And they form what we call those very beautiful, you see that, those snowflakes, right? We call that crystalline lattice, right? Because their hydrogen bonding is more stable, right? Are stable. But the running water, I mean, you are going to see that the hydrogen bonding are form, deform, form, deform, form, deform. They are not stable, the hydrogen bonding. And when you boil the water at 100 degrees, they can be completely destroyed because the water will become a gas. Another property of the water is also a very good solvent. Water dissolves polar molecule and ions. And therefore, the water can organize a molecule into a molecule that loves water, a molecule that doesn't love water. Here's the one. Either you love water and you interact with the water, you are going to be called water-loving or hydrophilic. Whether you develop a phobia against the water, I'm sorry about this, water-fearing or hydrophobic. You are repelled by the water. And one of the ones that they are repelled with the water is the fat. And water causes hydrophobic molecule to aggregate and assume specific shape. So if you, for example, if you make a vinaigrette, right? Vinaigrette, you are shaking it, you are going to see that it has tendency, the oil has tendency to be mixed. But when you let it sit down, you are going to see the oil exactly getting in the top. The aggregate in the top, the oil. And the water can form ions. The water can get hydrolyzed into hydroxide ion OH minus and H plus, which is the proton or hydrogen ion. We call it proton or hydrogen ion. Remember that the hydrogen does not have a neutron. He's only one proton, so it doesn't need a neutron, but he does have one electron. So water also is an excellent solvent. And the solutions or the substance that has been dissolved by the water is called solid. Water is a solvent, and the substance that has been dissolved on it, it's called a solid. So if I put salt in contact of water, he will destroy the ionic bonding. This is for ionic bonding. He will destroy it completely, and he will spare the hydration against H ions, sodium and chlorine. For convial bonding, of course, he's not going to destroy the convial bonding. Convial bonding is very strong. And for example, but he dissolved glucose, C6H12O6. So we call it that it's solid. The glucose is solid, but once he become in contact, of the water, he become sugary water or aqueous, C6H12O6. pure water, the concentration of ion, hydrogen ion, and hydrox equal the concentration of when he gets hydrolyzed, he make H plus and OH minus. The concentration of H plus equal concentration of OH minus, which is about 10 minus 7 molar per liters, and the pH is the negative, is minus log of the hydrogen concentration, which is pH equal 7. So this is a neutral pH for the water. So what is how, since she's neutral, we can determine what we call pH scale. And how we do that, for example, I want to know the pH of this substance, or what I do is put it in contact of the water. I know the water is pH 7. I know that the concentration of H plus equal 10 minus 7 molar per liter. If this concentration increase, that's mean my solution that my substance that I put in contact of my water, it's acidic. And if he has lower concentration of H plus but more concentration of OH minus, that means the substance I put in is basic, is not acidic. So let's go back to the pH scale. So the pH scale, acidic solution have a value less than 7. Basic solution have a value more than 7. And the most biological liquid in our body have a pH that range between 6 to 8. For just an example, our blood has a pH that's between 7.35 to 7.4, a little basic. So this is the pH scale. If you look at that, this is neutral. So neutral have as much OH minus as much as H plus. Basic has more OH minus than H plus, and acidic has more H plus than OH minus. So more than 7 is acidic, less than 7 is acidic, more than 7 is a basic. When I have as much as plus OH minus is neutral. And we have a substance that will balance, for example, if I told you about the blood, for example. Blood is a pH between 7.35, 7, let's see, 0.4, it's 7.38. And I'm drinking a lemon. The pH of lemon, I don't know if I have it over here. I drink a beer or cola. pH is 3. All right, lemon juices, pH is 2. Right? pH is 2. Is my pH in my blood will change to 2? No, it will remain. Remember, homeostasis. It will remain 7.38. Why? Because in my blood, I have what we call a buffer. A buffer is they are substances that resist the change of the pH. That it will resist to any change that will cause the pH to be changed. They release a hydrogen when a base is added. If I let's see, if I instead of let's see, I'm making baking soda or Great Salt Lake, pH 10. Oh God! All right, the others are house bleach and sodium chloride. They are very dangerous. I'm not those. So they are going to add release hydrogen. They are going to absorb those hydrogen ion. They are going to act acidic when it's needed and act basic when it's needed. So they are going to buffer. And this is the bicarbonate. They are going to be acidic or basic. This is to absorb more acid, and this is to absorb more basic. And let's stop over there. I see you for next chapter. Thank you.